This is the Smart Buildings Academy podcast with Phil Zito, episode 209. Hey folks, Phil Zito here, and welcome to the Smart Buildings Academy podcast. And in this episode, we will be talking about IP controls design and implementation. Now, for some of you, you may be wondering, what the heck is Smart Buildings Academy? Isn't this Building Automation Monthly? What's with that? Well, we just recently changed names from Building Automation Monthly to Smart Buildings Academy. That is the new name of our company, and you can find out more information at smartbuildingsacademy.com. And you can find the link to this podcast at podcast.smartbuildingsacademy.com/209. So everything I reference will be available at that link. In this episode, we are going to talk through what IP controls are. We're going to talk through how are they different than regular controls, how do you go about designing them, some concepts around IT, talk about main IP controls architectures, their design process, their install process, and a bunch more. So recently, I had a dozen Cyper 10 IP controls sent to me by Honeywell, and they were gracious enough to send them to us to use in our courses. We're going to be using them in our upcoming paid live training, which will be next week at the time of this recording, Wednesday the 15th and Thursday the 16th, where we will be going through the design and implementation of IP controls. We'll talk about how to actually go about designing and installing them. So they sent those to us. We're going to be using them in our courses moving forward. We're going to also potentially, I'm on the fence about this, but I'm pretty convinced that we're going to do this. We're potentially going to be using them for live labs for our customers, for our students, to be able to schedule time and log into the controller and actually work with the controller and work with Workbench. We'll know more about that in the coming month. All right, with that being said, though, IP controls, they've been around for several years now. Pretty much every manufacturer now has a line of IP controls. But you may be wondering, what are they? The best way to describe IP controls is to think back to a couple years ago when most manufacturers started to come out with IP-enabled plant controllers. So they came out with these controllers that were a combination of supervisory device and field controller. So they had the input and output capability of field controller. They had the programmable logic of a field controller, but at the same time, they had a IP connection to the greater IT network. And they also had a lot of supervisory functionality. You could connect field trunks to them. You could go and run supervisory functions like trends, scheduling, alarm, graphics. They would have web servers, etc. IP controls are the continuation of that plant controller, just filtering down to the other types of controllers. So the free programmable controllers that we're using at our air handling units, that we're using at our VAV boxes, they now come with the capability to have them IP enabled, as well as to have the capability of having, independent web servers, independent trending, scheduling, alarming, all built into these field controllers. Now we'll talk about what all that means a little bit later in this episode. But before we do that, I think it's good for us to realize how they are different from regular controllers. So they're very similar in that they have the free programmable interface, they have inputs and outputs. Some of them have the capability to have field trunks coming off of them to connect to other controllers, but they're different than regular controllers in that they, for one, are IP enabled. So they use the internet protocol either through Ethernet cables or through wireless. They also have supervisory device functions for most of them in the actual controller themselves. So it used to be that if you wanted to do trending, if you wanted to do scheduling, if you wanted to do alarming, you had to do that at the supervisory device. And then the supervisory device would forward that information to the server, and it would be presented at the server. Nowadays, what we're doing is we're actually, because, and to back up a little, the reason why we're able to do this now is the ability or the capabilities of processors, the capability of memory, the capability of storage has continued to shrink in size and increase in capacity. So you can have the exact same amount of processing power that you have in a supervisory device in a field controller package, in a field controller size. So now you can have those supervisory device capabilities, but they fit inside a field controller. So this enables us to have all that functionality. Now, this also opens up different use cases. Nowadays, we can do our trending, we can do graphics, we can have all of this in our field controllers, and in some situations, we're seeing supervisory devices disappear. Now, most of the manufacturers have switched to a licensing model where they license the software inside of their controllers, they license the software inside their supervisory devices, they license their manufacturing software. And this is done to fund their research and development. This is how they pay for continuing to support legacy controls as well as developing new control solutions. So now what you're seeing is the number of supervisory devices was not increasing at the rate of field controllers. By shifting to IP in the field controllers and now having licensing in several field controllers, we're able to then go and collect more, essentially share of wallet, in the form of service licenses. Now, not every manufacturer does this. There are several manufacturers that don't, and there are several manufacturers that do, but that's another way in which IP controls can be different than regular controls. Additionally, we are now, because they're IP controls and they use IP addressing and they use IT networks, we're now having to be more heavily involved with IT. And when we go about designing our IP controls, we have to understand several new concepts. Now, we've talked about this at length in several of our IT podcasts, and definitely we cover this in great detail in our IT for BAS Professionals course, which you can find linked to at the podcast page. That being said, I'm going to cover some of the main concepts real quick and get you familiar with them, at least from a hearing them perspective and understanding what they mean. You may not actually know how to implement these concepts after you finish this podcast, but you'll at least be familiar and you'll know what you need to kind of go and do research on. So with that being said, let's dive in. The first concept I want to talk through is the concept of a port. So a port, what a port is that a port is a physical connection to the network. Now, you've heard of TCP and UDP ports. If you've done anything with BACnet, you've heard of port 47808. That's a logical port. That is a logical address for a specific application on the network. What we're talking about are layer 2 ports. We're talking about ports in which your Ethernet cable connects to the device or the device being the field controller and or connects to the network switch. As we'll learn about a little later in the episode, there are 3 main IP architectures, and those architectures determine what ports connect to what, how you connect the wires between controllers, etc. At each controller, because we are using a network interface card, we have a MAC address. And that MAC address is the physical address of that network interface card. Now, at the network switch in which the physical field controller connects via typically Ethernet cable, that MAC address is associated with a port in an address resolution protocol table called an ARP table, and that ARP table is paired up with an IP address. Now, the IP address is the logical address of that field controller. And within a subnet, we have a set of IP addresses. We have a pool of IP addresses. Now, these can either be statically assigned. via static IP addressing, or they can be dynamically assigned from a dynamic host configuration protocol pool, or a DHCP pool. So a subnet will consist of a set of IP addresses that then can be assigned to the field controllers, and those field controllers' IP addresses are matched to their MAC addresses in the ARP table in the switch. Now that subnet can only communicate to devices within its subnet. Now that subnet could be across a physical LAN or across a virtual LAN that actually enables you to have the same subnet across multiple switches. Now, when you have to go outside of that subnet, say you want to communicate to another subnet, say your server's on a different subnet, or you want to communicate to the outside world, you need what's called a route. So the switches will then have trunk links coming out of their ports to connect the switch to the actual router. And the router will have a table inside it that tells the IP traffic where to go in order to reach the IP network it's trying to reach. So what happens is if there's IP traffic on a subnet and it doesn't know where to go, it wants to go to a different subnet, then it's sent to the default gateway, which is often the IP address of the router. And then that router goes and forwards the traffic to the appropriate network. So we just kind of covered a lot of concepts in regards to setting up the actual network itself. Now, there's several other concepts that need to be covered in regards to understanding IP controls. We'll talk about those a little bit when we dive into designing the architectures. But before I do that, I want to talk about security. Now, there's multiple different ways to secure the IP controls themselves. And this was one of the biggest concerns with folks, not because IP controls are inherently insecure. I would argue they're actually more secure than MSTP or FT10 controls because of the fact that they are using common IP protocols. They can be mapped into common intrusion detection and intrusion prevention software suites, and they can have firewalls and all sorts of capabilities assigned to them that enable the IT person to actually secure the device. In order for us to understand that, we need to understand how we secure at the port, how we secure the MAC address, how we secure the IP address, and how we can do certificating to secure kind of at the application layer. So the port itself can be secured in a multiple different ways, right? One of the things that people used to freak out about is someone would unplug the IP controller and plug in a bad device. Now, I often would argue, isn't the issue less of the IP controller and IP connection, and it's more of an issue that someone's in your ceiling unplugging your IP controller or someone's in your mechanical room? So first, we have physical security, actually securing the area in which we are connecting our devices. So you have to have physical security controls in place. Then from there, you actually have port security at the switch itself. You can ensure that the port is matched to a specific MAC address that is in that field controller. Granted, there is MAC address spoofing. You can also go and have MAC address duplication disabled or multiple MAC address disabled so that multiple devices can't connect via that port. There's a variety of things you can do from a port security perspective. Then from an IP perspective, there's several things we can do. We can look at the IP traffic and filter that traffic based on traffic type. We can go and use firewalls and firewall rules and access control lists. There's a variety of things we can do in order to ensure that our IP controls themselves are actually secure. And next up, we have this concept of certificating. Certificating is a way of validating the application itself, the device itself, and that its communication is basically who it says it's going to be. So certificating is another concept we can use in IP controls in order to secure them. These are very important concepts if you're going to be installing and designing IP controls, I really, really, really encourage you to go and study up on IP port security, Ethernet MAC address security, switch port security, IP, firewall and access control list, and certificating. Those are all concepts you should really have down prior to going and talking to an IT group. Now, here's the deal, to be totally honest. A lot of customers aren't going to have IT security groups. They're pretty much going to let you do whatever you need to do. It's only when you get to, hospitals, large corporate entities, maybe some larger school districts, that you're going to run into dedicated IT groups themselves who are going to be asking you questions like what I just explained. Now let's move into the design aspect of IP control. So there's really three design aspects of IP controls, and those are star, bus, and ring. So star is basically point-to-point IP addressing. The benefit of it is that if a controller goes down, you only lose that controller. And that'll be important when we start talking about bus and ring architectures. The downside of it, though, is that it takes up a dedicated switch port on a switch. Now, if you've ever bought a 48 port switch, they can be quite expensive, especially if you get managed switches. There's unmanaged switches like the Linksys stuff we put in our panels. And then there's managed switches, and these are things like Cisco and Juniper switches that actually have a command line interface. You can log into them, you can manage the ports, and they are significantly more expensive. In most buildings that are going to be of large square footage, you're going to have managed switches. And as you connect to those with your IP controllers, that can actually cost quite a bit per port. And some IT groups will actually charge per port for facilities to use their IP ports. So the star architecture, it's good for central plant controllers. It's good if you want, ultimate uptime, because if that controller goes down, it's not going to affect all the rest of the controllers, but it can be very cost prohibitive, and it will have an increased cost of wiring as well, most likely. Next up is bus. Bus is kind of middle of the road. It's very similar to how we wire up the daisy chain for our MSTP token ring. You essentially have one wire that comes out of the switch port on the switch. It goes to the first controller and plugs into the first controller's network interface card, and then that controller will have two network interface cards, and it will then have a Ethernet cable that goes from that controller to the next controller in a daisy chain pattern. The only downside of this, and folks are rectifying this, but if you recall, with MSTP controllers or LAN controllers, if you lose power to the controller, the communication buses are often electrically bridged, so they will still communicate to one another, right? They will go and communicate from just down the trunk, regardless of if the controller's on or off. Whereas in most IP controllers, they are not electrically bridged, they are bridged by software. So because of that, what will happen is to go from one network interface card to the other and then send the signal out, you need the controller to be powered. Now, many manufacturers are working to rectify this so that it's independent of if the controller's powered or not, and the signal will just continue on. But right now, that is a limitation. If you lose, a controller in the middle of the daisy chain, every controller after that you'll be unable to reach. Which brings us up to the ring architecture. Now, the ring architecture actually enables us to use two switch ports, one for one side of the ring and the other for the ending side of the ring. And then the controllers are wired up using a daisy chain. If one controller goes down and you can't reach the other controllers, then what will happen is the other port will then start communicating. Now, there's all this stuff about rapid spanning tree and blocking ports and open ports. I'm not really going to get into that in this episode. It is something we will cover in our upcoming live class. The important thing to understand is that when you're dealing with any of these architectures, they all have their pros and cons. Ring is going to use more wire than bus, but less wire than star, and it's definitely going to use less ports. But it's going to be a little more difficult to set up with rapid spanning tree protocol. Bus is pretty easy to set up, but it's the least stable in that if you lose any controller on that run, you are going to lose all the controllers after it. Star is great because it allows you to have a single run from the switch to the controller, but it is definitely significantly more expensive. When you're designing IP controls, the first thing I like to do is to figure out where my controls are going to be. And then once I figure out where my controls are going to be, then I figure out how the IDF or MDF is going to be set up and where my networking gear is going to go. Because what I have to make a decision on is this going to be a pre or a post shell setup? Because the reality is most IT gear is not going to be in the building until certificate of occupancy, or at least very close to certificate of occupancy. And if we're using IP controls and we need switches in order to connect our controls to them, then we have, two decisions we can make. We can say we're going to wait for the IP controls, and that's just going to delay the commissioning of our total building, and we need the contracting tier to be comfortable with that. Or we can use industrial switches and either replace those later or integrate those into the IT network. So that's our first kind of design decision, is we need to figure out where our IP controls are going to be, figure out where they're going to connect, and then we need to decide, are we going to use new IT infrastructure that is going to occur very close to certificate of occupancy, or are we going to use some sort of industrial switch that doesn't really depend on the environment being ideal? It can deal with temperatures and dust and all that. So that's the first decision. Once we've made that decision, then we need to work on our IP addressing scheme. We need to know what subnets we're going to use. We need to know what IP addresses we're going to use. We need to know if we're going to use static or dynamic addresses. We need to know what ports each device are going to connect to and what architecture they're going to use. Are they going to use star, bus, ring? What are they going to use? And then we need to have all of that documented and on our submittals as much as possible. Some folks will push back and say it's very difficult to get IP addressing approved on submittal sets. I would agree with you. IT usually does not have their IP addressing scheme worked out when you're going in the CD phase and you're working on your submittal set. That being said, you can still put address ranges. You can say, okay, we're going to use 192.168.0.1/24. And even if you go and end up using a 10 dot whatever IP address subnet later, because that's what IT wants you to do, that's fine. You at least have something to base your initial design and layout on. Because what you want to do once you've got that initial IP subnet and you know that you're going to be using dynamic or you're going to be using static and you've got your ports all figured out, then you can make sure that you have your routing all set up. So you want to get all of this well and good. And then and only then do you want to start working on your security. Oftentimes I will go and I will get all of this set up, get it all laid out, get it all kind of wired up to a actual industrial switch. And then either I will switch that industrial switch ports to the IT ports. I'll leave basically in the plenum enough of the Ethernet wound up on a J-hook that it can then be piped down into the IDF and put into the actual rack where the switch is sitting. Or if they let me use the actual industrial switches, then I'll just run a trunk port from the industrial switch to the actual switch in the IDF itself and connect that way. Once all that's done, right? Once all that's laid out, you also have to have your power laid out. You want to figure out what you're going to do with that. I recommend a transformer bank. So that way you have enough VA to go and power all these IP controls. Granted, with Star, sometimes you can use power over Ethernet, but that's more of an advanced concept. So those are all things I want to think about. Now, once I've got all that done, right, I've went through my design, I've laid it out, I got my submittals approved, I've actually implemented, then we want to perform proper checkout. And checkout includes scanning your IP addresses, making sure that your IP addresses are associated with the correct field controllers and that the appropriate field controllers are associated with the appropriate MAC addresses, and then making sure the appropriate MAC addresses are associated with the proper ports. So it's not like with MSTP controllers where you simply need to know MAC address for the field controller and then, like its device instance if you're doing BACnet, and you're good to go. With actual IP controls, you need to know not just their setup in the IP controller, but also what is it connecting to in the IDF, because you're no longer connecting to a supervisory device. You are now connecting to an IDF. You're connecting to a switch in the IDF or in the NDF. And the thing is, if you're connecting to a switch in the IDF or MDF, now you need to have a process that you've established with IT network admins around any updates, any upgrades that they do. If they are going to be upgrading network gear in their IDF or MDF or bringing stuff down for maintenance, you need to know that, because that can affect, let's say you're in a hospital and you have an IP controller, and that IP controller for that hospital is feeding back information to another IP controller on an air handler to go and then drive that air handler appropriately. Well, if the switch gear comes down for some maintenance, that could then take down control of that operating room. And so it's really important that you have a conversation about SLAs. That's basically the guarantee for your network being up, as it's called a service level agreement, by the way. And you also need to talk to the IT group about any disaster mitigation or any business continuity plans that involve that networking gear, as well as any upgrade plans that involve that network gear. I know this is going to be a little uncomfortable for controls folks, because we are not IT folks and this is not a normal conversation. So I really encourage you to have someone on your staff who is fairly proficient with networking. I would say has the equivalent of like 1 to 2 years worth of network administrator experience or network engineer experience. That would be good enough. You don't need much more than that, because we're talking fairly basic concepts here in the concept of, network setup, LAN setup, IP address subnet setup, routing, and then some basic things around port security, IP access control list, and certificating. Those are all pretty basic concepts. So there you have it. That is the difference between regular controls and IP controls, how you design IP controls, the main concepts around IP control design, the types of architecture, the actual design process and install process, and then kind of some decisions you can make as you're installing, whether you're going to use installed industrial switches, or you're going to use the IT switches that are usually put in post-occupancy or right before the certificate of occupancy is issued. I encourage you to go to podcast.smartbuildingsacademy.com/209. There you will find just a link to our IT course. You will also find a link to our upcoming live paid webinar, which will be our IP controls design and implementation webinar. In that live course, what will happen is we will go through the process of creating an IP controls design and actually setting up an IP controls design. We'll do that live on video, and then you'll be able to ask any questions you have during that. And like all of our live online courses, we will then create an online version that is not live that you will also have access to after the live class. So if you have any questions, I encourage you to reach out to us about that. Thanks a ton, and I look forward to seeing you in next week's podcast. Take care.